Hello folks, Professor Richie here. So, have you considered using camera-based machine vision? Machine vision and photogrammetry have often gone hand in hand. However, have you experienced issues like this? Certain features not being seen with camera vision. Take these two objects. They're the same, right? But wait, they aren't. One is a ball and the other a cone. Imagine we have shifting shadows and changing light. Machine vision will not detect feature edges properly in this situation either. And if the light is too low, camera vision fails. How on earth do we solve these limitations? Let me show you our vision. That vision is the Robo Replicator. First, let's talk about what is LiDAR. LiDAR, light detection and ranging. It shoots out a laser that bounces off an object and returns to the sensor. The time of the laser is measured as a distance to a point. Scanning with our sensor gives us all the point distances of an arc. We wanted a platform that could maneuver the sensor if needed. A robotic arm was the obvious choice. We attached a carving tool and a sick LiDAR sensor to the end of our robotic arm.
With the concept finalized, countless hours of research into conversion programming from sensor data to Python scripting was invested, and countless cups of black coffee were consumed. We used simulation software to obtain a proof of concept, and we had to design our robot's routine. We had to research and develop a Python module to make our programming communicate with the LiDAR. We took the polar coordinates from the sensor and converted them to Cartesian coordinates. The nature of LiDAR has an asymmetric resolution where the z-axis has more noise than any other. Thousands and thousands of data points were generated. Time to simplify. We developed an algorithm to oversample and statistically clean the data. At this junction, we needed to turn our cloud points into a computerized 3D object. We designed and created multiple iterations of tools for our Robo Replicator to bring our model to life.
With the programming solved, machining on our Robo Replicator can reproduce these scans, carving into these foam blocks. Now, to bring it to the real world, hit it, gentlemen.
Scanning in any light condition. Low lights, high glare, side lights, or even a strobe light. Success. That's all, folks. We hope you enjoyed our project from us here at Clover Park Technical College in beautiful Washington State.